What's up, guys? In this video, I want to go over a classic word problem that you can expect to see on your test. Now, not exactly this word problem, but any kind of variation of this, because it's very common for word problems like this to show up on the test. So let's go ahead and read through this. I'll work through it step by step, explain my process. So therefore, when you have to do a problem like this on your own on a test, you'll have some more confidence and know exactly what to do. So this one says a rectangular city park has a length of 45 feet longer than its width. The park has a perimeter of 810 feet. What is the length of the park? All right, so very important. We need to understand what is it we're trying to solve. We're trying to find the length of the park. Now, this comes into a lot of mistakes, which I'll highlight here at the end of the video of where students will make the mistakes. And typically, it comes into not actually answering the question. We like to do our math and then kind of forget what exactly we're trying to solve. All right, but before we even get into the mistakes or actually solving this, I want to kind of visually understand what it is we are looking at. So it says a rectangular park. So I'm just going to draw a nice little rectangle here. It doesn't need to be perfect, but for me personally, I always like to have a visual kind of representation or understanding of the problem. Now, not all word problems are going to be great for having a visual aid, but anytime you can do it, yeah, I think it's very important. The next thing is we need to kind of identify here our variables that we have. So it says we're dealing with a length and we're dealing with a width. Now, it doesn't matter which one you have here. We can say this is the length and this is going to be the width. All right, so L is going to represent length and W is going to represent the width. Sometimes we can go and write it down there, but for the sake of this video, we'll just keep them as the variables there. Now it says the park has a perimeter of 810 feet. So we also have the formula for perimeter we need to remember. So remember, perimeter equals 2L plus 2W. I don't know why I wrote just W. That's going to be a 2W, because basically if this is L, we know that's going to be L. And if that's W, then we know that's W, right? And the perimeter is basically the distance all the way around the rectangle. So you see W plus L plus W plus L, or you can just write it in this simplified form. All right, now the problem is we only have one equation and we have two variables. So when we have two variables, we either need to create two equations or we need to represent one of the variables within the other. And the important thing that it says here is the length is 45 feet longer than the width. So if I know, let's see, so you always want to start with the shorter one. So let's see, the length is 45 feet longer than the width. So if I say W equals the width, right? And now you could say length is going to, or L is going to equal the length. But another thing you could also do is the length is going to equal 45 plus W, right? Because the length is 45 feet longer than the width, right? So 45 feet plus the width. So whatever the width is, you're going to add 45. The reason why this is important here is because now I can substitute in my L into this equation with not using L, but I can use 45 plus W. So now it's going to have here is from my perimeter, I'm going to rewrite this as a 2 times a 45 plus W. That was my previous length, right? You can say length is the width plus 45. And then I still have the width, which I do not know, plus a 2W. Yeah, and then so now let's go ahead and solve for W. Now, again, you might be saying, well, Ms. McLogan, we're trying to find the length. Why are we solving for W? Well, again, what we need to be able to do is once we can identify what W is, we just need to add 45 to it to get the length, right? So now what I can do is I can apply distributive property here. And so let's just see 2 times 45, that's going to be a 90. And that's going to be a plus 2W, right? Make sure you multiply the 2 times both of those terms. And then we have this 2W right here. And therefore we have 2W plus 2W is going to be a 4W. So that's going to be a 4W. So that is going to be now the perimeter of the width with respect in terms of its with respect to its length, or in terms of its width only. Now, the other information it gives us is the park has a perimeter of 810 feet, right? Well, remember, perimeter equal this equation. So here's this expression that we have. We now know what the perimeter is, which is going to be 810 feet. So I can replace P, which represents the perimeter, with 810. We don't really need, you can use the feet if you want to, but then your terms would eventually be canceled out. So I'm just going to keep those off. So we'll have 810 is going to equal a 90 plus 4W. Now we just need to go ahead and solve for W. So to solve for W, first thing I need to do is undo what's happening to my W. So you can see my W is being multiplied by 4, and also a 90 is being added to it because that's a positive 90. So I'll go ahead and subtract a 90 on both sides. That's going to give me a 720 equals a 4W. And then I can go ahead and divide by 4. Now, if you think about dividing by 4, if you think about dividing by 4, it'd be like dividing by 2 twice, right? So you can think about this as 720 divided by 2 would be 360. If you divide that by 2 again, that'd be 180. Or you could also think of 4 times what would give me 72, and you could see that would be an 18. But either way, we're going to have a, because you just cancel out the 0. So we have 180 is going to equal a W. Now, again, remember that represents the width. We are looking for the length of the park. So now what we're simply going to do is say the length is going to equal a 45 plus 180. Now we just go ahead and add those up, and length equals a 225. And again, remember that is in terms of feet, which you can see in this case is going to be answer